Hello everyone and welcome to our new video. In this, we are going to cover the Terraform and go through the various aspects of the Terraform and learn about the Terraform in more detail. So that being said, let's start with the Terraform. Now Terraform, you will see that Terraform is gaining a lot of popularity nowadays because it follows the IAC based practices. Okay, so that is why you will see that a lot of people out there and a lot of companies are adopting the Terraform for creation of their cloud-based resources. Okay, now if you look at Terraform, Terraform has been created by the HashiCorp. That is the organization who have created the Terraform, and they are the ones uh, who have actually created and provide the support for the Terraform. Now they have a lot of open source technologies such as Nomad, Vault, Terraform, Packer, Vagrant. They all have been created by HashiCorp, and you will find that if you are looking for a production grade support for the Terraform, you will have to reach out to the HashiCorp for that. They provide the licensing. They also have an implementation of Terraform Cloud, which comes with its own advantages, which allows you to implement the Terraform as a SaaS-based service. And more about it, we will discuss later. So if you look at Terraform, Terraform allows you to provision the infrastructure and through IAC-based practices. What this means is that instead of you managing your infrastructure manually, creating the resources required for running your applications manually, you rely on Terraform, and Terraform can create them with the IAC based practices in a consistent and predictable environments. What this means is every time you are going to run Terraform, you will have a consistent environment which is almost similar across all your environments, like the different machines that you create for running your application. They will be exactly having the same configuration. That is what consistent means. And predictable simply means that because you have already written the infrastructure as code using the Terraform configuration language, this means that every time you run Terraform, it will create the resources as you have defined. So it makes your infrastructure and environments more predictable in nature. Now, if you look at the core concepts of Terraform, it allows you to define in the infrastructure in basis of code, right? And because you have now written your infrastructure as code, so you can actually put it under the source control like Git, which allows you to version your changes, and this will create your entire cloud management as a versioning, so that at any time you are making any change, it will go inside your source code source control system, and this will allow you to easily revert back the changes in case there is some issue that comes across after making the change. So you can easily fall back to the previous version. This helps you to reduce the downtime, at the same time increase the uh, availability of your infrastructure, increase the confidence for deploying the newer changes, and manage your infrastructure in a consistent manner. Then it comes as both as a declarative and imperative. So declarative simply uses the declarative syntax in which you tell basically how many instances or how many secrets and different resources you want. Terraform is going to implement that. Now, if you want to get a very specific details, you can actually use the imperative model as well within the Terraform, describing each parameter, which will allow you to get the resource in a very specific manner which you want to control. Okay, so it supports both of the syntax. Now Terraform is idempotent. What this means is that you can keep running Terraform, apply again and again, but it will only make a change when there is a difference between the current state and the desired state. That is what idempotent means. So you can be sure that this is the idempotent environments are only making a change when there is a difference between the current state and the desired state. Now, all your infrastructure that you are going to create with the Terraform is going to be consistent every time. So because you have already written it as an IAC code, so every time you create, it will be exactly the same way what you have defined in your IAC code. Okay, so it always results in the consistent model. Now you can actually work on push model, where after creating a change, you can push the changes by using the Terraform apply, and it is going to apply the changes to your infrastructure. So this is how the push model is implemented. Now, eventually what happens is that if you want to keep applying the changes so that no one is able to make a change manually and it does not distort your configuration into a configuration drift, so you can implement the pull mechanism as well, in which case, because Terraform is idempotent, it will only make a change when there is a difference. So if someone changes anything manually, the Terraform will be going to revert back. This is a very important concept within the IAC, because once you start implementing the IAC, all the changes should go uh, using the code only. You should not be making any changes manually. Now, if you look at the infrastructure as code benefits, so you will find that it allows you to have automated deployments. This is very important because every time you're going to do a deployment, it can require certain amount of resources, services to be created within the cloud on which you are going to deploy it. Like if you are running, let's say, the containerization, it might use the secrets, it might use the parameter store and things like that within the AWS for running your application. So you can actually deploy it, configure, write the Terraform configuration, and it's going to provision everything and do the deployment for you. So it's going to result in a consistent environments with the configuration that you have already written. It will exactly provision the infrastructure in that way. Now it also creates a repeatable process. Usually uh, whenever we work on the application, we require the similar kind of infrastructure for multiple applications, right? A lot of things are going to be repeated. So once you have written it, you can actually reuse the components, and usually the reusing of the components are done with the help of Terraform modules, which we write, and these modules can be used again and again, and you can same module can be used by multiple teams, and this is going to allow you to reuse the same configuration again and again. Now, this reusable components, you are going to usually create an upstream from which repository from which the other teams can usually fork their changes. And once they fork the repositories, they can actually create their own environments and config. So what happens is that you actually use it like a framework where multiple teams are using your centralized modules, and these modules, every time then you have to make a change, you can make a change in your upstream, and the other teams can actually take a pull. So those changes will be inherited by the different teams working across the different verticals. So this is how you can actually implement a framework, a broader framework, which will help you to implement your environment practices. Now, this also helps you to document the architecture. Anyone who is willing to read the Terraform configuration should be able to understand how your overall infrastructure has been provisioned and maintained. So this also helps you to document your entire infrastructure, making it easier for the newer people to get onboarded on the same. Now, automating the deployment with the Terraform, you will require a provisioning resources. So you will require a provision which is going to actually apply those changes, right? So we will be seeing this more in the lab session. Now, whenever you are running the Terraform, the best part here is that you can actually plan your updates. So Terraform supports Terraform plan, which allows you to actually see the changes which will be implemented, right? So Terraform supports Terraform plan, and it will show you the details of what changes will be made to the resources within the cloud. And later on, these are the changes. Once you are finalized that this plan works for you, then you can go ahead and implement it. Now it usually integrates with the source code, source control system, like that is Git. So if you are integrating it with the Git version control system, all the changes becomes repeatable in nature, and you can easily manage the different versions over a period of time. So you will understand at a later point in time how your infrastructure reached to a particular state. If you want to review some changes, why a particular resource was changed, then the source control system is going to play an effective role in that. And next is reusing the templates. Now reusing and is one of the major concepts within the Terraform, and this is very important because this allows you to write once and use many times. This is one of the most important advantage of IOC, so that you don't have to do the repeatable things again and again. Once you create these templates, they can be reused again and again for provisioning the similar type of resources. Like, let's say if someone is requiring an RDS to be created, they can again recreate the entire RDS with all the best practices that you have identified. So it's kind of a practice where all the RDS will appear in a similar way, but used by different teams. So data is actually going to be different, but most of the configurations, that the parameters that you are changing, they are going to remain the same. And you can be sure that your all the infrastructure is following the best practices. Now, this is also very useful in case you are going for some audits. Then there are different policies which needs to be maintained across the entire environment. As your infrastructure grows in size, it becomes more and more difficult to manage such um, uh, policies across all the resources, and you cannot guarantee it. But Terraform allows you to guarantee it, because this is, you can define it in the configuration, and every team is going to use it. So you can be rest assured that they are following the best practices which you have initially defined. So this is how the Terraform plays a very important part in the infrastructure deployment. Now, if you look at Terraform, Terraform actually is a declarative tool. So you only need to declare what you want within your infrastructure, and Terraform is the one which is going to implement those changes. Now, you don't need to tell Terraform like how eventually those changes need to be implemented. But at the same time, if you want like to put pass all these parameters, you can do it. Okay, but Terraform itself can take the defaults and create your most of the resources. Now it uses, the Terraform is going to use the HCL, which is very important. This HCL stands for HashiCorp configuration language. So HashiCorp has its own implementation, which and it basically uses the Golang, right? So this is the Golang is the one which is actually powering it. The Terraform binary that you get, it has the all the code inside it which has been written in Golang, and they compile it and create a single binary which you can download, install, and then eventually run through the Terraform. Now it's going to help you evolve your infrastructure safely and predictably. So you can see and plan the changes before implementing those changes. It will clearly show you if a change is going to be implemented or some resources is going to be deleted. And based on the plan that you have seen, you can actually apply those changes. So it makes it much more safer to implement the changes within your infrastructure, because the clear changes are visible when you run the plan phase, and it's predictable as well, because the entire configuration that we are going to run is completely predictable, and we can predetermine how our infrastructure is going to be created. Now it basically applies the graph theory to the IaaC. So this is the another thing you can actually whenever you are manipulating the resources, the graph theory, if you understand about it, it creates the linkages between how these resources will actually be provisioned. So those graph theories are implementable within the Terraform. Now, Terraform is a multi-purpose composition tool, and it composes multiple tiers. That is, like, you can use the Terraform for SaaS, PaaS, and IaaS. So all these are different tiers which are there, like software as a service, platform as a service, and infrastructure as a service. You can use the Terraform for multiple of those, and Terraform can create those resources and manage that in a repeatable way for you. Now, Terraform is a plugin based architecture model. So you can actually plug in, like use the different modules and plug in to eventually run the Terraform. Now it uses a backend of the HashiCorp company, which the backend has been created by HashiCorp themselves and HashiCorp DAO. This is basically the guide principles and design which the HashiCorp suggests you to create and manage the infrastructure in the best possible way following the IAC practices. Now there are Terraform is not a very specific in its offering that only Terraform is offering these services. You can find that there are other tools as well, like CloudFormation and Heat. Heat comes uh, uh, Heat is basically used within the OpenStack for managing your OpenStack deployment if you are running the cloud within your own data center. Then comes Ansible, Chef, and Puppet, which is the configuration management tool. Then there is like Goto, SDK, Fog, Apache libcloud, which also helps you to manage the cloud resources. And then there is like custom tooling and scripting, which you can write on your own, because all these cloud providers are basically providing these scripts which can help you manipulate and manage the infrastructure as well. Now, we are actually going to compare it with the Terraform and see why the Terraform has a edge over all of these things, why you should be using the Terraform instead of going with any of these approaches. What are the advantages you will find there? So if you compare like AWS CloudFormation with the OpenStack orchestration, such as with the Heat, okay, you will find that AWS CloudFormation you can only use in the AWS. It's basically locked in. You cannot change a cloud provider. CloudFormation is built to work with the AWS. And then with the Heat, you will find that it's an open source. So again, you will find that a lot of versions are going to be released over a period of time, and the development also is supported by the open source community. Now, initially it was released in 2011, while the Heat was released in 2012, so not much differences there. You will find that sources hidden behind a scene. Now you do not actually, you cannot see the changes which is happening in the backend. So CloudFormation is going to make the changes and give you some idea what is happening overall, but it will completely hide what is happening behind the scene. At the same time, Heat provides the CloudFormation compatible and query API for OpenStack. So it is also compatible with the CloudFormation. At the same time, you can actually query using the API for OpenStack. Now, the CloudFormation designer is available. What this does is it provides you a GUI interface where you can actually drag and drop the different components, and it is automatically going to provide you the code and eventually change it according to that. So it makes it a little bit easier. But obviously, AWS is a managed service, and it is the CloudFormation is free to use. AWS doesn't charge you for using the CloudFormation. The charges are actually in the resources which you are manipulating from the CloudFormation. So charges are there, but using the CloudFormation, AWS doesn't charge you for that itself. Now, you will find that the CloudFormation uses JSON and YAML. So it's basically a subset of JSON. So YAML is a subset of JSON. So again, it uses both of those syntax. Now, you will find that rollback actions and stack updates are supported within the CloudFormation. And there is a Heat dashboard in case of the Heat if you are using with the OpenStack. And then there is like change sets which are there. So you can create the different changes which will be reflecting within the change sets within the CloudFormation. In case of Heat, it's basically through the YAML configuration file that you are going to write. Now, you will see that there are different configuration management tools which can also manipulate the cloud-based resources for you. But these are specifically the configuration management tools which are used to manage the configuration across the multiple VMs. Now, ideally, you should not be mixing the configuration management tools and the resource orchestration tools, uh, because the resource orchestration tools, we are actually using it for manipulating the cloud-based resources. So you should not be actually manipulating. All right, so there are different approaches. Like if you see Puppet and Salt, they basically uses a declarative syntax, while if you see Chef and Ansible, they use imperative approach. You have in a declarative syntax, you are going to actually declare what you want, and the tool should be automatically able to figure out how to implement those changes. That is what declarative syntax means. Imperative, you will have to provide more details of exactly the platform specific. Like let's say if you are running on CentOS, you will have to use the Ansible module, so for installing the packages resource. While in case of Puppet, it is automatically able to get the facts through facts, like which package has to be used, and it will automatically determine whether it's apt or yum and implement the changes. So there are like these two different approaches on which these tools can be categorized and they can eventually work, but all of them does support the managing of the cloud-based resources. But obviously there is a steep learning curve in each of those and the orchestration capabilities of all of these tools. So you will have to learn about them and go through in the, obviously it is more, and but once you are able to get through the documentation and understand the overall concept, you should feel pretty much comfortable writing these configuration. Now there are different languages through which they have been written, like Chef has been written in Ruby. Puppet has like JSON like syntax and Ruby, but they have their own domain specific. Puppet has the DSL basically, which is a combination of JSON and Ruby, right? So that is only implementable to Puppet itself. Then Ansible has been written in YAML and Python. So if you are aware about it, you will find more comfortable with these tools. Now, if you look at Boto, Fog, and Apache libcloud, so they are providing the low-level access to the APIs. Now, within the cloud, everything is an API. So again, you can manage these APIs with any of these SDKs as well. So they provide some of the libraries which are focused to the specific cloud providers, and other providers common interface with a few different clouds. So not all of the extensive support would you will find over there. And it inspires you to create the custom tooling. So you can yourself has to define the standards, which are actually a downside, because when you define your custom tooling, it might not be that much scalable, or the other people might not be aware about it. So it becomes difficult to onboard the other people on the custom tooling that you have defined. It might work according to your requirement, but then scalability and ease of understanding are the challenges which you might face across them. Then comes your, if you look here, it might be error prone, because then you are going to define your own custom tooling. Obviously, you have to thoroughly check it, write the test cases, and it's a very tedious work, and you are actually reinventing the wheel, which means that there is already something which has already written for the same purpose, but then you are trying to recreate. So it will take efforts, and it will be more error prone, and it will be a tedious work. It will require more human hours, because then you will have to put on all the efforts, all the logics you will have to write yourself and test them out, which will take more time. Then it provides you the minimum viable features for implementing them, not the full out of box solutions for making it work and customizing according to your requirement. And it is like a slowness and the impossibility to evolve, adopt quickly to the changing environments, which is true in case of cloud providers, because they themselves are very rapidly growing, introducing the newer services. So it becomes difficult to manage the pace there and keep it in sync with the cloud providers out there and make it relevant throughout, right? Next is Terraform is not a cloud agnostic tool. What this means is that some people think that once they write the configuration within the Terraform, they can actually run it across all the cloud and the systems, which is like, it's not a magic wand, right? So it's not that once you write it, you can run across all the cloud providers. Majorly what you can get is like, it embraces, first of all the cloud providers. What this means is that Terraform can actually run on all the clouds. But what this means is that it provides a common language and orchestration of the infrastructure resources, but the infrastructure resources which you are going to define within the Terraform, they are themselves going to differ. So like there are different conventions within the different cloud providers, because they don't have the similar terminology and the resources. That's why you cannot just write once and run across all the cloud. Although the approach and the writing style will remain the same, but then the resources itself are going to differ. So you cannot run the same cloud, right? This is what it means. But the advantage of running the Terraform is that it is supported for all the major cloud providers out there, and you can use it with any of them, right? And it follows the same writing approach, but the resources are different. So if we compare the Terraform with Azure, okay, so you will find that both of them supports the infrastructure as code. Now within the Azure, you use the ARM based templates, which allows you the manipulation of the Microsoft Azure cloud resources. Now Azure actually uses JSON while it uses the HashiCorp config language HCL, and the ARM templates does not provide you with the execution plans while Terraform does. Then the dependencies are explicit, and you will be need to including implied the dependencies in case of the Terraform. It is not supported multi-cloud, so if you are running in Azure, you can only use the ARM templates in case of Azure only, but in Terraform you can run across the multiple clouds. Obviously the configuration will differ, but then you can run it Terraform across multiple clouds. Now configuration is limited, and it is also limited, but it can do some storage tasks as well. Now rollback is supported, and so is the case with the Terraform as well. Azure preview features are there, and it's inclined with the ARM snippets, and key value support is there, same as with the Terraform. Then you because the state is not there, so corrupted state is not an issue. But if you are not properly storing the state in case of Terraform, then it can be an issue. It supports the DevOps, both of them supports the DevOps practices, and it is actually free, and Terraform supports both the free and the purchase support. Now if you are getting a purchase support, you can reach out to the support team which are supporting the Terraform for that purpose. Then there are like parallel deployments are supported by both of them. So when you run locally, ARM templates will need to be uploaded and deployed across the Azure. Terraform uses the basically the REST calls for a client machine. This is how Terraform is going to make the changes. So you can delete the resources in portal and not worry about the state, right? But in case of Terraform, it's not like that. And because it implements the state, right? So if you delete it manually, right, then obviously this is going to create issues with the Terraform, because Terraform will see that the resource is not there. So there is a difference in the state, it will be implemented. Then it supports comments via an attribute. It also includes the comments via block comments, and speed. It can take a while to execute the ARM templates, and Terraform is particularly very fast, and it deploys as a single item, right? Both of them supports the math function, both of them supports the count, and both of them supports the module. So ARM templates actually supports link templates. Terraform has their own modules, and you can write your own modules as well. And it requires many templates, and both of them can be referring the existing resources. In ARM templates, we use variables. In that, we use the Terraform, we use data resource type. Okay, and reverse engineering resources. So you can export to the Visual Studio, and you can import the objects within the Terraform like that. Now let's compare the CloudFormation with Terraform. So you will find that CloudFormation, first of all, it's not very open in nature. So you cannot get all the details which is happening in the backend. It is actually managed by AWS. So it's a closed source, right? It has been developed within Terraform, within the AWS, and the AWS does not share with you the specific details how the CloudFormation is making the backend changes. But then Terraform is completely open source, and there are multiple contributors towards the Terraform, and it has the very extensive documentation, and there's a community, so you can also contribute if you like within the Terraform. Then it is more suitable for working in the AWS cloud. It is cloud agnostic. What this means is that you can actually use the Terraform across multiple cloud vendors. You are not limited to a one particular cloud. So this is one of the biggest advantage of using the Terraform. Then CloudFormation provides you a GUI access without any cost. The GUI access within the Terraform does has it, which comes in the form of a Terraform cloud, which is kind of a SaaS based offering from the Terraform, and it is, you will have to purchase the enterprise license for that purpose. So you don't have to manage the state, you will need to manage the state yourself in case of Terraform. And then it supports the YAML and JSON. It also supports JSON and HCL based configuration. Now it has a nested stacks which let you work with multiple templates. This concept is hard to grasp for the beginners and limitations, because you are actually using the nested slacks within one into another, which causes the CloudFormation a little bit more complex and difficult to understand for the beginners, and it has the limitations as well. While in Terraform, we have the multiple TF files, which makes it easier and creates a distributed configuration as well. So it becomes more easier. Now, if we compare the CloudFormation and Terraform, so we can compare on them with on the scope basis. In the CloudFormation is mostly for the AWS, while Terraform is cloud agnostic, so you can use across the different cloud providers. Then it uses the license and support. CloudFormation is provided free with the AWS. So if till the time you are working with the AWS, it is free for you. You can actually use it to manipulate the AWS resources. And while creating the resources, AWS will charge you for that, but does not charge you for using CloudFormation. So Terraform is open source. You can use both the free version and you can also use the paid version, like the SaaS offering which the Terraform has to provide. If you talk about syntax, they use the JSON and the YAML based templates, which are somewhat convoluted. In case of Terraform, you will use the HCL based templates, which are much more easier to interpret and understand, like what are the changes being implemented through Terraform. And it supports modularization. If we talk about the modularization, the CloudFormation does not use the modules, while Terraform actually use the modules, which makes it repeatable to use, and you don't have to rewrite the entire code again and again. Then it makes the user experience. If we talk about user experience, CloudFormation provides you a user interface to create, modify, and present the resources and dependencies with the graphically. While if we talk about Terraform, the Terraform is an open source version which actually supports only the command line, but then it also provides you the SaaS version, which is a GUI based, but you will have to purchase the enterprise license for that. Then if we talk about the state management, CloudFormation manages the state within the out-of-box managed service. So you don't have to worry about the state. CloudFormation automatically does that for you. Within Terraform, you will have to explicitly store the state into some shared like S3 bucket with the DynamoDB locking, or when you are using the Terraform SaaS-based approach, it can automatically manage the state for you as well. So import the existing infrastructure. So CloudFormation cannot be used to manage the resources treated outside the CloudFormation. What this means is that if you create a resource outside of the CloudFormation, then you cannot import that resource within the CloudFormation. But in case of Terraform, it is supported, and you can actually import the state, but at the same time you will have to write your own configuration for that. Okay, but yeah, you can import it state-wise so that you don't have to delete and recreate the resource. Now you can actually verify the changes. The CloudFormation offers changes that you can set and verify the changes. In Terraform, you are provided with a plan so that you can actually verify what changes will be implemented, and if you are find good, then you can go ahead and apply the changes. Then there is like rolling updates, which is supported. The CloudFormation can perform the rolling update of the auto-scaling groups, including the rollback case in feature, but rolling updates are not that supported like in the auto-scaling groups, and automated rollbacks are not supported within the Terraform. Okay, so here is a here's a comparison on the basis of like the different important thing like configuration languages. So how the Terraform and ARM templates work out. So you will find that both ARM and CloudFormation are similar, but Terraform actually scores here the code readability, how easily you can read the configuration that has been specified. Again, the ARM and the CloudFormation are basically similar. Terraform scores over it because it uses HCL, which is very easy to understand, right? So if you have general understanding of the cloud, the Terraform understanding will also be easier for you. Then there are exceptions which can occur. In this case, ARM and CloudFormation basically scores over the Terraform. So it is more easier to understand in case of ARM templates and the CloudFormation rather than the Terraform. Then the error tracking, again, error tracking is more easier with the case of CloudFormation and the ARM. Audits are more easier in case of ARM and CloudFormation because they track all the changes and writes them out, right? So you can, it becomes easier to audit through these ARM in the CloudFormation. Tracking the capabilities. Now this is again with the CloudFormation and the ARM template, right? So deployment monitoring. So again, here the CloudFormation scores more. Tooling support. Again, the CloudFormation and the ARM template supports more. Modularity. This is where the Terraform actually works, right? So then there is versioning and management system. Again, Terraform scores over in this case. Validation system, again, Terraform scores over it. Maintainability, again, Terraform scores over it. And multi-platform. So these tools are not multi-platform. So if you look at this configuration, what this tells you is that Terraform is more suitable for you if you are looking for a tool which is able to allow you to create the versioning, allow you to validate, use it across multiple platform, multiple clouds, maintain it easier, you can read it easier, you can make the configuration easier and maintain at the same time, implemented without depending upon a particular cloud. In those cases, the Terraform is an obvious winner as compared to the ARM and the CloudFormation. But then there, if you are looking for some capabilities, deployment monitoring, you are sure that you are not going to shift in future, then the CloudFormation and ARM templates are better suited for those kind of approaches. Now, if we talk about the architecture of Terraform, so you will find that there is a Terraform code which makes a remote procedure call to the provisioner. What are providers? So providers are the one like the cloud providers, where various SaaS-based providers, or like your PaaS providers, right? So there are different sorts of providers which are out there, mostly your different types of cloud or specific software providers as well. So you those are the providers which are actually going to provide you the resources where you want to manipulate them. Then there is a provisioners which are actually going to make the changes using the plugins which are provided by the Terraform, and it's going to manipulate the resources. So what happens is that you are going to use the plugins and the provisioner and use the client library of the Terraform to make the API calls back to the streams, upstreams, and this is how you are going to manage the changes through the Terraform. Now, if you see the architecture, so individual will be writing the Terraform configuration file. Usually, how do you identify a Terraform configuration file? Any file which is ending in .tf is a Terraform configuration file. Okay, and whenever you are going to run the Terraform configuration file, it's going to generate a Terraform state. Now, Terraform state is like a reconcile loop which stores all the information in the form of a key value pair inside the Terraform state. This is how Terraform knows what changes the Terraform has done over a period of time, and this is how it knows the resource state within the providers like your AWS, DigitalOcean, Microsoft Azure, Google Cloud platform. So this state is very necessary. If you miss out on the state, then Terraform will not be aware what is the current state of your infrastructure, and it will try to recreate it. If those resources are it again find, it might give you an error. If something is deleted and Terraform is not keeping a track of it, it will try to recreate that. So maintaining the Terraform state is very important, because this is how the Terraform knows what things you have already provisioned. Terraform can easily do this, provided that you make the necessary provisions to store the state properly within your Terraform. Okay, we are going to discuss about that more detail when we do the lab session. So next is Terraform config. You are going to write the Terraform config, which is going to generate the Terraform state. Now, Terraform config will actually be executed by the Terraform core, which is going to generate the state files. And on the basis of that, you are going to decide what is your current state of the infrastructure, what is the desired state of the infrastructure, and how the changes will be implemented across the various providers like your AWS, Kubernetes, and Fastly. So it can manage your SaaS, PaaS, and the SaaS-based infrastructure. Okay, next is your Terraform core. Now, how actually the changes are made? The Terraform core actually makes the RPC call, that is remote provisioning call. And there are like different cloud providers, provisioner, and the plugins, which makes the changes to the using the client library. Now, if you look at the plugins, there are various external static binaries. There are RPC procedures which has been written between the core and the plugin. Then there is a provider also comes as a plugin and implements the provider's CRUD-based operations. So you can easily implement the CRUD-based operations within the cloud providers using the API call that the Terraform makes. Okay, so you have these are the four different important files. There is a Terraform state file which stores the state within the Terraform. Then there is a Terraform TF wars which is going to store the variables information within the Terraform. Then there is a providers, Terraform providers.tf, which is actually going to store the information about the cloud in which you want to make the changes, the provider essentially. And then there is like the instances.tf where the actual instances are modified. So providers, these are basically the providers in which you can you are seeing here, these all are basically the providers. Okay, so this is how you are going to write your code. Basically all the variables goes inside the tf wars, and the state is generated using the .tf state file. And there is a instances dot Terraform instances dot tf, or the main dot tf, basically where you write the actual main code, the main configuration within the Terraform. Okay, so these are the major configuration files. Okay, now if you look at Terraform components, there is a Terraform executable which executes your configuration file. Providers are the one which identify your cloud-based resources, whether you are using AWS or Azure. Like those are basically the providers. Then Terraform makes an API calls to the cloud providers in order to manipulate the resources. You are going to write the various Terraform files which I just showed you, like tf-wars, okay, then main.tf, and the providers.tf file, like that, in order to manipulate the Terraform resources. Then it's whenever you are going to apply the changes, it's going to result in a state file, which is actually storing all the details about the changes that the Terraform has done. And there is a Terraform config file which is going to make the you are going to write the changes which you want in your resources within the config file. Okay. After that comes your providers. So obviously there are multiple types of providers which are supported, like IaaS, PaaS, and SaaS. All of them are supported. There are multiple cloud providers, resources and data sources, and multiple instances which you can actually act like a provider in case of Terraform. So some of the examples are AWS, Google Cloud Platform, Azure, VMware. All of these are example of the Terraform providers. Now, if you look at the providers, it can be integrated with the various API tools, like you can integrate it with GitLab, GitHub, Bitbucket. All of them are having the runners which can actually execute the Terraform and help you manage the resources with the help of Terraform. So, and you can integrate all of these, basically allow you to create the CI/CD pipeline with the Terraform. Okay, so this is how you can use these tools. Okay, then obviously Terraform can manage the Docker, Kubernetes, Nomad. Okay, these all are basically the tools which are being used to manipulate the resources. And there are DNS provider, Palo Alto Networks, and F5 big load balancers. Okay, so multiple calls you can make through Terraform in order to manage it. These all are basically acting like a providers within the Terraform. Now here is an example of a provider. Like if you talk in this case here, the Azure is the cloud provider, and it is showing you the subscription ID, client secret, tenant, and alias with the help within the Azure using the Terraform. Okay, next is Terraform Syntax. So Terraform uses the HashiCorp configuration language, HCL. Basically, it does not uses JSON because it's more readable and editable. It uses the interpolation, and it also supports the condition functions and templates. So these are the important things which we require. Mostly the conditional, various condition can be executed, functions you can write, and templates and interpolation is supported. So this what makes the Terraform much more powerful. And here is an example for you where it is trying to manipulate a resource like AWS instances and creating an instance like app by just providing the AMI and the instance type. So this is a very minimal amount of code which is actually going to create an AWS instance called app within the provider AWS. Okay, so similarly, you will find another example here to create a local resource. Okay, now within this, you will find that it is actually creating the, this is an example from the main.tf, which is manipulating, creating a random string, and which is actually creating a count. Now you can actually pass the default values, which is very important and a very specific thing. Every time you create a variable, try to pass some default value so that if the user is not providing it, at least that value is some value is getting input, because without that default values or a wrong value, the more resources can be created, or either it's going to give an error. So at least if a default value is there, so minimal amount of default resources will be created, right? And then you can override the characters and specify the minimum special, like this will help you the users to specify at least the minimum values. Then outputs.tf is there, which generates when the Terraform runs and generates the result. That outputs.tf can print that data. You can mark the data as sensitive as well, in which case it will not show the output within the screen, so that if it has some sensitive data. Now there are variables which you can use within the AWS. Now these variables can get the input from the user as well. You can integrate it with the pipelines and pass this in the form of parameters for maintaining across the different environments. Then there is like provider. So providers is basically the like the different providers out there, the cloud different types of cloud providers out there, so you can use their resources as well. Then there is like the resources which you want to manipulate, like in this case we are manipulating the AWS instance, and the output can be also displayed by running the Terraform. So once the resource gets created, Terraform will show you the public IPs, the keys, the load balancers, DNS, like that. You can all generate it with the help of Terraform, so that you don't have to go specifically into the AWS cloud dashboard and check out those outputs, right? And here is a code example of the provider where it is generating the outputs of the it's taking the various input and creating the resource group within the Azure cloud. Okay. Now, if you see the Terraform syntax, it's very up forward. It uses a variable keyword and use the variable name, and you have to provide the input in the form of a key value pair. So whenever you can use the hash. Hash is like a comment within the Terraform, so it's not going to get evaluated. Every time you have to get a value for a variable, you can say $var.name in the curly braces, and it's going to give you the string value, okay, of the variable. Then you can actually get the map element using the var.map and get a specific key, get the map element as well. Then you can get the list element as well using the Terraform variables, okay, if there is more than one value. Now if you look at the provider, so there is, you can put the provider name, key value, and you can actually create the data objects, okay, and the you can actually call those data objects later in point in time. Like here we created a data object, data underscore type and data underscore name, and data call that type and it with the attributes and the arguments that we want to pass. So if you look at the Terraform workflow, so initially you will find that there is a DevOps practitioner, basically the people who are working within the DevOps team. They are going to write the Terraform configuration, and they are going to initialize the backend, plan the changes, and apply those changes. So initialize actually makes a call and creates a backend where your Terraform state file is going to be stored. Right, this is where it downloads the latest Terraform state file and determine the state of the changes which needs to be implemented and created. Now you can actually store it on your local as well. So it's going to initialize your local directory and store the Terraform state file there. Or you can store it on the S3 bucket and enclose it with the DynamoDB, so that there's a state level locking which has been applied. Then there comes the plan state, where when you apply a plan state, it will take a it will show you the changes which is Terraform is going to implement. Think of this like a dry run. Instead of making the actual changes, it will just show you what changes will be made rather than actually implementing those changes. Once you are convinced that your plan is good and the things that you are seeing are getting changed is what you are trying to make a change, so you can go ahead with the apply. When once you apply, it's going to make the Terraform like the changes and going to update your state file, which is going to be stored locally. So this is actually holds good when you are working individually, right? So this practice is like working good, or you are having a very small team. In those cases, it's a good practice. You can actually run like this Terraform. And if you look at the init command, the command will never delete any of your configuration. So you are exactly sure that it won't be making any backend change. It just initializes a backend. It calls a checkpoint like checkpoint-hashicorp.com, and it creates a Terraform RC file, which enables the plugins, which through this you can actually, if you want, you can disable the checkpoint as well. So it parses your configuration, checks your syntax for if there is any syntax error in your configuration. It's going to check it for the provisioners and providers, and it can create a lock.json, which is a SHA-512 plugin hashes with the .terraform. Like, so it can lock your resources, which can so that you are good to apply the changes and the other people are not making the changes at the same time. So if there is a lock, it will give you an error saying that another person is going to make a change. So make sure you run the Terraform init command before going to plan and apply the changes. Now it can load your backend configuration, and backend initialization happens when you run the Terraform init command initially. Okay. Now, once you have done that, you can actually plan and apply the changes. You are going to start with the plugin with the provisioners and the providers. So providers are the one through which you are going to apply the changes across the multiple clouds. Now you are going to build the graph. Terraform Code traverses each vertex and requests each provider using the parallelism. What this means is Terraform can execute the changes within parallel, and it does a resource validation, like the resources, the configuration that you have defined, it is actually validating on the cloud providers end, because if you have specified something which is not being supported by the cloud provider, or you have provided a value which does not correspond to a particular field, it will give you an error. So you can actually implement you can pass the backend as nil, use the local instead, in which case the state file will be generated on your local machine. Now, backend usually refers to where your state file is going to be stored, because it plays a very important role for that. You can also output the plan into a file, because when you run the Terraform plan, it just std out the plan on your screen. So if you want to store that plan for sharing with someone else, or keeping it as a check for a later point in time, you can output that to a file as well. Terraform core is going to calculate the difference between the last known state, which it gets from the state file, TF state file, and your current state, like the state in which your infrastructure is currently in. And it's going to present a difference between the Terraform plan operation and their terminal. So that is how the Terraform is going to apply the changes. Now, next is Terraform Destroy. So Terraform Destroy is a command which helps you to remove the or destroy the resources. So it measures twice and cut. It's going to remove the resources. Consider using the target flag, so that a particular target is going to be removed when you destroy. Avoid running on the production, because if you just run the Terraform Destroy and whatever configuration that you have processed, if the permissions are there, then the destroy is going to actually destroy those all the resources. Now usually, as a best practice within the production, what you can do is you can remove the permissions to actually destroy the resources, because this can come at a very big cost, because Terraform is able to create the entire infrastructure. Depending upon how you have written your configuration file, it can destroy all the resources which you have previously created. It can cause a bigger outage if this command is run in the production. In order to prevent this, we normally remove the permissions, and even if you run the destroy, in that case it will fail on the cloud provider end, because you are missing the permission. In that case, what you can do is you can destroy the resources manually. Keeping it manual process is much better as destroying with the Terraform. But again, if you understand properly what you are going to destroy, you can particularly use this command in the destroying the resources as well. Now, there is no retain flag, means that you are going to remove the resources from the state file instead. Okay. And Terraform Destroy tries to evaluate the output, and they can refer to the non-existing resources as well. Preventing destroy should let you succeed, and you can't destroy a single resource with count in the list. So these are the things that you need to remember while using the Terraform Destroy command. Now, if we talk about the Terraform state file, it's basically implemented in a JSON. It implements, you should implement a locking for it. Otherwise, you are going to get the conflicts within the version control system. Then it uses a local or the remote state. You can store it directly on your local machine where you are going to run the Terraform plan or apply, or you can execute it with the help of your CI/CD tool that is for the remote execution as well. And you can manage the multiple state file for the multiple environments. Now, if you look at the state file, it acts like a backup of your, you should always take a backup of your state files using the versioning and the encryption, because state file is very critical for the Terraform. If you miss on the state file, it will delete all the resources. It will not work. And if you have a corrupted state file, that is also a bigger issue. If you are versioning it, you can always call back. You can always see the changes which has been done in your infrastructure, and keeping it encrypted can increase the security of your state file. Do not edit manually in any other circumstances. You should not be editing manually, because the chances are you are going to corrupt the file. Now, if you look at the Terraform TF state file, you will find that there are lineages, which is unique ID and persist after initialization. There is modules main section, then there is serial increment number, then there is Terraform TF version, implicit constraints are there, then there is version, so state version is there. Now within the Terraform state command, you can actually use the move to move and rename the modules. You can use rm to remove the resources from the state. You can use the pull to observe current remote state and list and show the debug the modules which are there in the state file. Now, Terraform state is going to keep the remote state of your infrastructure. This is how the Terraform knows what is your current state of your infrastructure. It stores it in a file called terraform.tf state. We already discussed about it. There is also a backup of the previous state called Terraform TF state backup. When you execute a Terraform apply, a new TF state backup is overwritten. What this means is that you are already having a terraform.tf state which is showing you the current state. Now once you apply Terraform plan and then you apply the Terraform changes, it's going to your resources are going to update, so it's going to override your previous file with the newer file or with the current state of the infrastructure, right? So this is how it executes your Terraform apply changes. This is how the Terraform keeps a track of your remote state. If the remote state changes and you hit the Terraform apply again, the Terraform will make the changes and correct the remote state again, right? So every time you run a apply, Terraform is going to make a changes and update your Terraform state file. You can terminate the instance that is managed by the Terraform and apply changes again. It will get started again. Okay. So next is Terraform state. You can keep the Terraform TF state in a version control system. It will show you the changes which is happening over a period of time. It gives you a history of the Terraform TF state file. It allows you to collaborate with the other team members. Unfortunately, you are going to get the conflict if you are not going to implement the locking mechanism within the Terraform TF state file. Now, local state works in the beginning, but when your project becomes bigger, you might want to store the state in a remote system. This is how you are going to work. That is much more safe rather than storing on your local machine, because eventually that can result in the disruptions and your machine going corrupted. So in those cases, you will lose out on the Terraform state, considering storing it on the remote system. Now, Terraform TF state can be stored, saved remotely, and the backend functionality, the default backends for the Terraform are S3, which is very widely used with the open source Terraform. Then there is like console you can use Terraform Enterprise. In case of Terraform Enterprise, you don't have to worry about the Terraform state file. The Terraform cloud is automatically able to store the state every time it implements a change. The console comes with the locking, and S3 you will have to use the DynamoDB for locking the changes, otherwise the conflicts will occur. Okay. Next is if you look at the simple workflow, so you are going to write the variables.tf, store all the variables. Main.tf, this is the first file which is executed by Terraform, and there are outputs.tf, which is going to show you whenever you are going to run the init command, it's going to go to the backend and it's going to call your providers and provisioner. It will identify to which cloud providers you are making the changes and download the plugins for the same. And it's also going to create your current workspace, right? So this is how what happens when you run the init command initially. Okay, and these Terraform files should be there because it looks for the main.tf in order to initialize the backend for you. Okay, then comes the plan stage. So when you run the plans, it's going to evaluate your terraform.tf vars, variables.tf, main.tf, and outputs.tf. It's going to plan and show you within the current working stage, like what is the current state. It will call the Terraform TF state file and check the current state and show you what changes will be implemented. Now, workspace usually refers to your environments. You can have different workspaces like dev, test, stage, prod, like those. Okay, then you can once it will show you all the output directly on the std out. If you are using a file out command, it will store it into the file output, right? Then there is like a apply command which is going to make the changes and initialize the module and implement those changes to the infrastructure. Then there is like destroy, which is going to initialize your backend and remove the resources from that. This is how all the changes are getting implemented within the Terraform. Okay, now, if you see Terraform apply basically applies the state. Terraform Destroy is going to remove everything from the resources from the Terraform and the cloud providers. Then FMT is there. FMT is basically for the Terraform files to write in a canonical format and style. This is important when you are managing an enterprise grade infrastructure. It makes it more readable and you should implement the Terraform FMT for that purpose. Now, next is Terraform get to get the updated modules, and Terraform graph to represent a visual representation of the configuration and the execution plan. Then there is Terraform import. Terraform import allows you to import the resources which might have been changed outside of the Terraform. So it's going to only import the state of those changes, but you will have to write the configuration on your own. Okay, next is Terraform output. Terraform output shows you the output of the resources. Once you have made the changes, it will display the output on your screen. Terraform plan is used to initially check what changes have been implemented by the Terraform. If you think that all the changes are looking good, then only you should implement the plan. Next is push. So Terraform push is going to push the changes to the Atlas and HashiCorps like that. Then there is Terraform refresh, which is going to refresh your remote state, and it can identify the differences between the state file and the remote state, right? So if you are thinking that your state file might be outdated, so you can try to refresh that. Then there is like Terraform remote to configure the remote state storage, and you can actually show the human readable format of your state plan as well, which will help you to understand the state of your current infrastructure. Now the state is used as a advanced state management. Basically, it stores it tells the Terraform what is the current infrastructure state. It's like a reconcile loop for that purpose. Then there is a taint. If you are marking a resource as a taint, it's going to be deleted and recreated by the Terraform that the next apply happens. Then there is a validate. Validate is going to validate your Terraform syntax, whether it is having some issues or not. Then there is untaint. Untaint means that if you have previously tainted a resource, and if you want to remove that taint, you can untaint your Terraform resource. Now Terraform advanced workflow, so you will find that if your as your DevOps team grows, so you are going to put the changes within your version control system, all your Terraform configuration files, and you are going to initialize the backend. Whenever you run the init command, it's going to initialize your remote state from the backend. These backend, it can be S3 and DynamoDB or console. Okay, like that. Okay, and this allows for the team collaboration, because now the multiple people can take the lock on the backend state file and implement the changes. And every time you run a plan, this will take a lock on your previous state file and then show you and apply the output. It will not implement the output, but it will show you. And if you run the apply, it will update your state file as well and store it back in the cloud, and the changes will be applied to the cloud. Now this is for a smaller team. Now if you are having the multiple teams, then again the changes will be still committed inside the version control system, and you are going to write the application modules. In that cases, there will be application modules, network modules, monitoring modules. So different kind of modules will be there, and each of them will be having their own workspace. And the teams can apply the remote state, store it from the remote storage, and they can initialize, plan, and apply those changes. And this is how the changes will be applied across the multiple clouds out there, right? So you can implement those changes. Multiple teams can use it to implement the changes within the cloud in the respective resources. So we are going to perform a demo in which we are going to see the Terraform files and deploy the configuration changes like that, right? So this is all for this video. In the next video, we are going to examine the demo with the help of the Terraform and create the changes within the Terraform within the AWS account. So that's all for this video. If you have not subscribed to our channel, please do subscribe to our channel to receive such videos directly in your inbox. Thanks everyone for watching this video. See you in next video.